Hello everyone, welcome to Civil Mania. So today I'll be doing the design and analysis of a circular water tank. So let me first of all open STAAD Pro. Okay, new project, space, meter kilonewton. Okay, finish. Now let me close this grid system and go to the geometry and run structure wizard. From the structure wizard, open frame models. Yeah, this is a one kind of circular frame, so I will click on this part. Then what will be the length? Let me keep the radius as 5 degree as 360 degree. What will be the length? Let me keep the length as 10 meter. Length means the total height of the water tank as 10 meter, and number of bays along the length, let me keep as 3. So let me keep here first bay as 4. Sorry, let me keep this one as 3 meter, 3 meter, and 4 meter. So let me check whether it's okay or not. Applied. See, as you can see here, this is the diagram. So let me, okay, this is the diagram which I made it, so I can even show you by the help of dimension from here to here. What is the dimension? It's 4 meter from here, sorry, from the here to here the dimension is 4 meter. So the top portion is 4 meter, then the all other height is 3 meter and 3 meter. So I can show you 3 from here to here, it's 3 meter, and from here to here again it's 3 meter. So this is how I have created the water tank. Okay, so this is the first bay, second bay, and third bay. Okay, so this is the water tank which I have created. There are so total height is 433, which is equal to 10 meter, and number of this is the length. Height is actually calculated in terms of length, and number of bays are 3, 1, 2, and 3 bays, and total the radius of this one is 5, and diameter is 4. Okay, so I hope the figure is clear to all of you. Now let me do one thing. Let me view from the front view, that is view from plus Z. Now let me cut the section, that is this is the section. I have cut the section. Now view from top view. After viewing from the top view, let me do one thing. Let me draw one beam. Okay, I will delete afterwards, but let me draw one beam. I have made the beam. After drawing the beam, let me click on this beam and mark the center point. Insert the node at the midpoint. Okay, done. After that, you have to copy this node and rise it. Copy it and paste it again by Ctrl C and Ctrl V, and rise it in Y direction by 0.5 along the positive Y axis. So okay, done. So let me see from the front view. I hope it's clear to all of you. So this is the point which is raised by 0.5 meter. Now, yeah, I hope it's clear to all of you. So this is the 3D view. Now you have to, now let me do one thing. Now let me delete this beam and this beam also. Okay, I have deleted the beam. Now let me join here. Yeah. So now let me view this diagram in the 3D view. See, see this one is this portion is a bit raised. So now this is the bottom portion of the tank. So let me do one thing. Let me view from the positive X and see, you can simply click on cut section and select to view, and simply you can cut this section, or in a different manner I can show you one another command is again view the full structure, then go to again z-axis, then simply click on this beam, simply click on this beam. Now go to view. After going to the view, or you have to just wait. Yeah, view selected object only. Even I can click on this one, as you can see here. So this is the portion which I have selected only. Now from the top view, now let me do one thing. Now let me draw two beams. Yeah, after drawing the two beams, now let me select the two beams, and after selecting the two beams, okay, so I have selected the two beams. Now I have to intersect both the beams. Yeah, let me select both this. Yeah, after selecting, let me go to the geometry and intersect the selected members. Then just you need to intersect them. Okay, so they are being intersected now. So let me again view from the 3D view. So I hope it's clear to all of you. This is how we need to create a circular water tank. But as you can see in the figure, the bottom circular part is also there, so I have to remove that part. Again view the full structure. Now go to the front view, select the beam and delete the beam. Now let me again view the full structure. Yeah, now it's okay. Now what I need to do is, see, now I have to fill the sides and the top, the that is the uh, cover person with the plates. So now let me do one thing. Now let me select this portion and Yeah. Now I have selected the full box portion, that is the full circular portion, and now I have to either I have to manually cover the full portion by the help of this add 4 noded plate, or simply you can click on this fill floor grid with plates. Simply click on this one and click on OK. Now you can see in the 3D view, see this the full circular portion is covered with plate. Now even the top portion I need to cover it with plate. So view from the positive x-axis. Now select this portion and view from the 3D. Yeah, now again need to fill the floor with the plates. Now I will view again in the 3D. See, the bottom as well as the side portions are now being filled up with the plate. Now the bottom portion is present, sorry, the top portion is covered, and the full periphery or the full circumference side is being covered. Now the bottom portion is left. We have to cover, now we have to do the surface meshing in the bottom portion. So now let me again go to this view and click on this beam, and after clicking on this beam, now again go to the view portion and view selected object only. Now from the top view, either you can click on view selected portion, or you can cut the section by the help of cut section command. Now this one is done. Now I have to do surface meshing. So as you can see here, this one is the generate surface meshing. Click on this, and now yeah, now what are the divisions? Now see, as you can see here, there are 10 divisions on each. So let me click on OK. Just wait for some moment, because the surface meshing part is going on, and it will take time, because each plate I have divided into 10 subdivisions or 10 surface meshings. See, so numerous or unlimited number of surface meshings are being created in the bottom plate where the water will be stored. So then always remember that the more number of surface meshing you will do, the more it will become accurate. So this is the main reason why STAAD Pro was taking a bit time. Now you can see the 3D view of the structure. This one is only the bottom portion. Now let me view the full structure. Yeah, this is the full structure. I hope it's clear to all of you. So it's taking a bit time because it's creating a rendered model, and in the bottom plate numerous number of surface meshing is being created, so it is taking a bit time. See, in the bottom part numerous surface meshing is done. I hope all of it's clear to all of you. Surface meshing is actually a part of finite element method, and this surface meshing is actually done in order to provide the accuracy. Okay, so I hope it's clear to all of you. Now let me give the properties to the beam. Let me go to the beam portion, general portion, then property, then provide, define. Go to define and rectangular. Let me provide the column of size 0.4 by 0.4 column, and beam of 0.3 by 0.4, and also define the thickness of the plate as 0.5 2. Add it. Okay, done. So now see, plate thickness, you have to simply click on assign to, use assign to view as plate thickness. Simply assign it. Where the plates are being present, it will be automatically assigned. Now go to the rectangular portion. So this is for the columns. So now you have to select beams parallel to y-axis. So assign to the selected beams. Now for the beams, so for the beams, what you have to do is you have to select all the beams. So let me select the beams by the help of the beam cursor. I will first of all select this portion, then press the control button and press the, this is the beam and this one is also the beam. Now view from the 3D structure. Yeah, everywhere all the beams are now being selected. Now assign to the selected beam and click yes. Now let me view in a 3D manner. See, this is the rectangular water tank which is being created. So I hope it's clear to all of you. So this is the 3D view. Now let me go to the support portion and provide the support. First of all, create fixed support. Now select the fixed support, assign to the selected nodes, assign it. Now the fixed support is being provided to all the columns. After that, go to the load and definitions. Here in the load and definitions, now go to the load case details. Sorry, here I will be applying the various type of loads. First of all, let me go to the wind load and wind. So let me go to the wind load and apply category 3. As per Delhi, I will be designing. See what is the height of this structure, 10 meter. Least lateral dimension is, what is the least lateral dimension? The least lateral dimension is 10 meter also, because its radius is 5 meter. So it's a round figure. Okay, okay, so it will be created up to the height of 10 meter. Okay, add it, intensity of 1. Now simply assign to view, click on assign to view, assigned. Yeah, now click on seismic load, seismic definition, add it as per IS 1890 2002 2005. Now click on generate city, special moment resisting frame. Okay, medium soil, damping ratio is 0.05. Generate, edit. Now self factor, edit was 1. Now what is the member load? Member weight is, here all the beams are of size go to calculator. Beams are of size 0.3 by 0.4 into 25 equal to 3. So uniformly distributed load of 3, edit, close it. So add S3 and click on front view, select the beams which are placed in a horizontal manner and click on apply to the selected beams. Okay, but not for the top beams because they are not horizontal beams in the top lead. Now go to load case detail, add dead load. Sorry, first of all I have to do the calculation for the seismic load. Seismic load X, seismic load Z. Now after that wind load X, wind load Z, then dead load, then live load, done. Okay, edit it, dead load, live load, done. Now go to the seismic load and add seismic load X factor 1, add it in the Z. Again go and seismic load factor along Z, add it. Now go to the wind load along X. Wind load along X is in the X direction factor is 1 and each height is from each height minimum. What is the minimum? Minimum is actually 0 and the maximum is 10 meter. Add it. Now along -1, done. Now along the Z, 1 0 से 10 1, again -1 0 to 10, add, done. Now go to dead load. In the dead load part you have to provide the self weight of -1 factor, done. After that floor load. Now after that in the floor load let me take the thickness of the floor as, let me go to the calculator. What is the floor load? The floor thickness is 0.2 into 25. Okay, because the density of the concrete is 25 and its thickness is 0.2, so 5, so -5 is the pressure which will be present on 4 meter to 4 meter, sorry, not 4 meter to 4 meter, 6 meter to 6 meter, because at a height of 6 meter minimum and maximum the floor is present. assign to view, self weight assign to view. So as you can see here, this is the floor load. Now again go to the dead load and add plate load. In the plate load, take the pressure as how much will be the pressure of the water. So again go to the calculator and you have to find out how much the pressure will be created. Okay, so how you will calculate the pressure? Go to the calculator. So or I'll tell you the procedure how to do it. Okay, so pi into d square, diameter is 10, pi into diameter square divided by 4. This is the area into its height. Its height is 4 meter. Okay, so this is the volume. So this volume multiply by the unit weight of water, which is equal to 1000 kg per meter cube, or 9810 Newton per meter cube. So multiply by 98. So this much is the weight. So divided by this much is the pressure. This much Newton. This much Newton is the pressure. This much Newton divided by 1000. So the 3081 kilonewton. 3081 kilonewton is the pressure which is being created. Okay, but upon the area, actually this much is the load divided by again area. So this much divided by 3081. Okay, so you have to find out the pressure. See, pressure, what is the formula for pressure? Pressure is equal to load by area or force by area. So this much is the force I have calculated divided by area of the circular plate. 3081, I will divide it afterwards. So pi into area. I have to find out the surface area. So what will be the surface area? Seventy 3081 divided by 78. 3081 divided by 78. So 39.4. So this much is the pressure. Take the pressure as 40. So minus 40 is the pressure in the global y direction. Add it. Now let me again create another load. So this is the load for the pressure of water. Now let me create again in the plate the hydrostatic load, that is first of all select the plates. Okay, plates. Go to the plate cursor and select. Let me do one thing. Let me go to the front view first, then after that click view, only selected object. Let me go to the front view, select the beams, select this beam, select these plates and select this beam also. Yeah, see, this is how I have created. Now deselect these two beams. Yeah, view, selected object only. Now go here, edit, go to the plate load, go to the hydrostatic and select the plates. Now plates is equal to all the plates. Let me do one thing, just wait. I need to select all the plates of the periphery. So let me go to the view from positive X. Let me select all the plates. Yeah, all are being selected directly. See, all the plates are now selected. Now click on done. Now what will be the pressure? As you can see here, W1 is at the bottom and W W2 is at the top. So W2 though it's written maximum, but always the pressure at the bottom of the water tank is maximum, so W1 will be maximum. So keep this one as the 40 and they keep this as 10 and interpolate along global axis. What is the direction of pressure? The direction of the will interpolate along the y-axis, but the direction of pressure will be along the local x-axis. So click on add, close it. See, all are now created. As you can see here, all the pressures are now created on all the faces of the walls, that is on all the plates. Now you have to apply this pressure. In order to apply this pressure, go to this view and select this plate, select the beam. Just wait. Yeah. Now let me do one thing. By the help of beam, view, selected portion only, then click on 3D view. Yeah. Now click on this one, assign to the view. Just wait. Let me select the plate. Assign to the selected plate. Click on assign. But it will take time as there are numerous plates are present at the bottom. See, now also the applying process is going on. Yeah. I hope it's clear to all of you. So these are the various things which are created. Now go to the live load and click on add. In the live load, Add floor load or in the y-axis of minus 2 kilonewton in the global y. Add it. Okay, done. So everything is now done. Now simply what you have to do is you have to go to the analyze and print, add it, close it. Yeah, so I hope it's clear to all of you. So this is the report. So these are the various reactions after the analysis is over. Then so this is the analysis part. You can see this is the deflection diagram. This is the deflection diagram. This is the shear this is the bending moment diagram, and this is the shear force diagram. Let me off other. Okay, after that you have to do the again go to the design part, and in the design part do the click on concrete design IS456, define the parameters. Select the parameters first, unselect all, then click on compressive strength. Click on compressive strength, yield strength of main reinforcement, yield strength in strength of secondary reinforcement, maximum size of secondary reinforcement, maximum size of main reinforcement. Okay, define the parameters. M30 I will 30,000. Now reinforcements 500, FE 500, 500,000. Then again FE 500, so 500,000. Main reinforcements of 20 mm, secondary reinforcement of 12 mm. Done. Now commands: design of beams, edit, design of columns, edit, design of slab element, edit, and take off, edit. Now close, assign to view, assign to view, then again assigning to view, then again assigning to view, again assigning to view. After the design of beams, your design of beams is in the beam design. These are the beams. So assign to the selected beams, design of columns, select beams parallel to Y, assign to the selected columns, design of elements, assign to view, and concrete takeoff. Yeah, so everything is now done. Again go to analyze and click on add, click it, then and again do the analysis. Okay, So the designing process is going on. You have to wait for some moments. So the analysis design part is over now. Go to the post processing mode. Done. See, as you can see here. Now click on beam cursor. Go to the beam, and you can check for the concrete design and all these parts. Now even you can go to the report, and you can check for this all. Print on OK. See, go to the next page, and this is how you can take the printout of the full report. So I hope it's clear to all of you. This is how you need to do the design and analysis of a circular water tank. I hope. And if there is any doubt, then you can just comment me on the comment section, and please subscribe my video, and thanks for watching.